Hi, this is Laura Chappell, and I am here with,
Jenny Spicer.
and today we are going to take you into the Bundle Protocol version 7 using ION, the Interplanetary Overlay Network, and Wireshark. The title of our presentation is
Hitchhiker's Guide to the Deep Space Network.
So this is what we're going to be covering today. Our mission is to provide you with an overview of ION. We'll show you the test suites and the various tests, and we'll show you how to run tests. We're going to also show you how to customize Wireshark for analyzing space communications. You're going to see when we run these tests that the addressing in the tests are a little bit strange because they're using the loopback address for these tests. And that is kind of funky in what it does with Wireshark. So we'll deal with that in just a moment. We're going to run a couple of tests on ION for you. Jenny, do you want to tell them a little bit about the two tests we're going to run?
We are going to be using bping, which is basically a ping equivalent using the bundle protocol. We're going to get an echo back and be able to analyze the communication between two nodes. And then there is BP chat, which is actually sending text and having it reflected.
Yep. And so we're going to be showing you how to analyze their use, those two little applications' use of Bundle Protocol version 7. And we'll take a look over at the spec because we're going to see some things in the Bundle Protocol header that we just want to point you to the spec so you can see what other numbers might be in that location and what the spec says about what it's doing there.
We will also be providing the trace files that we capture during this. So you can analyze on your own and build your own bundle profile.
Yeah, we're not going to hand you the bundle profile that we make in this session. That's a great lab exercise for you to learn how to customize Wireshark so that it works for you. You don't work for Wireshark. Okay, so let's go ahead and get started. All right, so on my system, the base operating system is Windows, but I have installed the VMware Workstation Player 16. And inside of there, I have an OpenSUSE 64-bit instance running. This is where I've installed ION. And I also, you can see I have Wireshark running on the left-hand side. It's not doing a capture right now at all. But let's start by looking at the ION directory structure. Jenny, you want to take them in for just a bit of a tour on the directory structure?
Yeah, absolutely. So the minute you get into ION, the core directory has a whole bunch of supplementary scripts and supporting scripts, as well as a very helpful README. If you want to get into ION, highly recommend looking at that as your first step. Mainly, though, we're going to be looking at the tests directory, where there are a lot of pre-written tests that we can run to capture traffic.
All right, so there is the test directory. And on the left-hand side, before we run any of these tests, I'll make sure that I start Wireshark capturing on the loopback adapter. Do you want to talk a little bit about why I'm capturing on loopback, Jen?
So ION generates traffic over the loopback adapter. Even though it is using interplanetary node addresses, it's still going to be using 127.0.0.1 for every single packet that's going to cross your machine. So that's where you're going to want to capture your traffic. You're going to want to type /run tests, and then the name of the test you're going to run. We're going to start with bping.
All right. Now, before we run the test, though, I want to make sure that Wireshark is starting to capture the traffic. I don't want to miss any of this traffic here. So over in Wireshark on the left-hand side, I'm running Wireshark as root here. And I'm going to choose the loopback adapter here to run my test. So I can double-click on that loopback adapter. If for some reason you want to put in a capture filter for this, which I wouldn't recommend, there shouldn't be a lot of other stuff on your loopback adapter probably. But if you do want to put in a filter so you're only capturing loopback traffic, you could go into your capture options area and type in host space 127.0.0.1. and that will capture only the traffic to or from 127.0.0.1. And you'll see how interesting this is in a moment. Keep in mind that if you also wanted to capture on an external adapter, you can select more than one adapter for your capture. I'm on my system, I'm just holding down the control key to select multiple adapters. But for this, we'll go ahead and just start capturing on the loop back. So I've started the capture process running. I'm going to come back over here and hit enter to start the test running.
When bping is running, you're seeing the output of the script as it is running through, including notes about what the test is currently, or what is currently being tested. And if you want to later, you could actually look inside of the script and see the notes from the creators of Ion of how this is running and what each section is doing. Right now, you can see that it's verifying certain errors are not occurring. And each one of those dots is a packet that is being received.
One of the things I think is interesting is that for every test you run in Ion, Ion's not running in the background at any point until you start a test. Then it launches Ion, goes and grabs all of its supplemental files for configuration, things like that, runs according to that script, and then it cleans itself up at the end. So you can see it's doing a kill M at the end here. And that's where it's terminating all of the Ion processes. So now let's go over to Wireshark and let's focus on this trace file and what we can see. The first thing I want to do is I want to make a profile for this communication, for analyzing the bundle communication or analyzing Ion communication. So in Wireshark, to do that, I'm going to right mouse click in the profile area down on the status bar, and I'm going to select new, and I'm going to give it a name. I'm just going to call it Ion, and then I'll say OK. You'll see that we have the default profile, and then we have some other profiles that are already created for us in here, but I want to make a brand new one. So now in the bottom right-hand corner, it tells me I'm in the Ion profile. And if you want to move around to different profiles, you just simply click on that right-hand side of the status bar and select the next profile you want to move to. But here's what's interesting in this. You can see that in this test, the traffic ran from 127.0.0.1 to 127.0.0.1. So this source and destination columns, those are pretty useless. So let me bring this up so we can see a little bit more about the bundle protocol here, and I'll pop up to the top packet here. I'm going to right mouse click and I'm going to hide the source and destination columns because they're worthless to me. They don't tell me who the actual source was, who the destination was. So let's take a look inside this bundle header in here. And again, we're talking about bundle protocol version 7, and that's RFC 9171. Now I know my test is done, so I'll go ahead and stop the capture process up above that. So there we can see the UDP header right there, destination port 4556. Below UDP here, we have the DTN bundle protocol, DTN standing for delay and disruption tolerant networking. And there's a summary line here that tells us the payload size, the number of blocks that are in this, and we'll talk about the blocks in just a second. But there I can see in the summary line the destination and the source. So this packet is going from interplanetary networking 1.2 host to from interplanetary networking 1.1 host. We'll talk about the time in just a moment and the sequence number in just a moment. Okay, Jen, do you want to start telling them a little bit about this indefinite array piece here?
Yes, so this has to do with a new feature of bundle version 7. Bundle version 7 will use CBOR encoding.
There are 3 settings available, preference settings available in Wireshark for the bundle protocol version 7. If you were to right mouse click on the bundle, anywhere in a bundle protocol header and go to protocol preferences, you'll see compute and compare CRCs, reassemble fragmented payloads, and then attempt the heuristic dissection of the BTSD payload. And if I choose that, there it is. There's that CBOR that shows up underneath. And Wireshark saying, I think this is the style of communication being used here, that this is being done in this format. So it's concise binary object representation.
So bundle version 7 stores its blocks in an indefinite array. This helps it be flexible with how many blocks are included in a single packet and keep it in the fewest number of bytes we can. CBOR encoding starts an indefinite array with 9F. So that is it beginning and saying we have an indefinite array of blocks coming up. And at the very end, you will see FF. That is the termination of this indefinite array. That has to do with just the standard break encoding from CBOR.
That's interesting. And, I've got the hex window up too, and you can see that that's the actual end of the packet. What follows this is an expert warning. And we're going to talk about that in a moment, because we're going to alter Wireshark's expert notification system, because we don't want to be warned on what's inside of here. And we'll talk about that. I'm going to go ahead and I'm going to turn off that protocol preference to use the heuristic dissection routine. All right. So beyond the starting point where it says indefinite array, which is what's coming up, then we have the primary block. And I'm going to expand the primary block. And let me bring this down so we have just a little bit more room. And I'll bring it up here. So the first thing you have is the version field that's telling us we are using bundle protocol version 7. And then below this, you have bundle flags, and you can expand these to see what's happening here. This is requesting status time in a report. So basically it's asking our target to report back to it. And down below that, let's just focus on some of the interesting fields here, because otherwise we could go through the whole entire RFC on this. But the destination endpoint and the source node ID are important to us, as is the report to node. And if you just click on the summary line and you drag it up to be a column, it's just going to tell you that that exists. So this is not the way you make a bundle destination and source column. So I'm going to right mouse click and remove this column. What you want to do is you want to expand this section and go down to the summary line that's inside square brackets in that section. And we want to drag that destination URI, Uniform Resource Indicator, up to be its own column. And now I can read that. That's just what I want to see. I'm going to do the same thing for source right here. Actually, I'll put source on the left. And then the last one I'm going to do this for is the report to URI. Here. Okay. All right. So below this, I don't know if Jenny, if you want to hop in on any points in here, I'm just going to keep going if that's okay. And you can just hop in if I skip over something.
I just wanted to point out that for URI, it's identifier, not indicator.
Oh, see, I always say that.
I think I learned that from you, and now I'm checking myself on it.
Oh, I'm sorry. I'm sorry. Yeah. All right. So we have the creation timestamp, which is where you say when you created this bundle that's being sent out. There is a sequence number field in here, the lifetime. So you could think of lifetime as almost a time to live value in here. When this will expire. And I'm going to collapse this section and go to the next section just at the bottom of this primary block. So below the primary block, Wireshark has this piece in square brackets called the bundle identity. The identity of this bundle of information is a combination of the source address and the delay and disruption tolerant networking time value and the sequence number. So here's something that was interesting that Jenny and I found when we were looking at the RFC for the bundle protocol. DTN time, delay and disruption tolerant networking time. We're used to epic time, but Jenny, you want to tell them what DTN time is based on?
So DTN time starts with the year 2000. It also ignores leap seconds, which they make sure to know.
Yeah. So I thought that was pretty interesting. There's a lot of issues with time in space. And we're going to talk to you a little bit about where you can learn more about space comms at the end of this presentation. We have some recommendations for you. All right, so I'm going to close up the primary block here, and now I'm going to go to the next block, this canonical block here after that. Now here you can see that this block begins with a type code. Just like if we look at our primary block, it doesn't have this type code in it because you have to have the primary block in there. That has to be the first block you're always going to have. So there's no reason to really have a type field in there when we know the first block is going to be the primary block. But now we have a type code telling us what this block is. And we can see that there's a canonical block there, 1, 2, 3, 4 blocks after the primary block. And so now might be a good time to show you the RFC for this type code value. So let me pop out to the RFC. All right, so section 4 in here talks about the blocks. And we can see that there are all these other blocks besides the primary block. These are called extension blocks. One of them is previous node, which is what we see right here. Block type 6 identifies the node that forwarded this bundle to the local node. You'll see there's a bundle age block. There's a hop count block. And there is a list in here of all of the blocks. Let's see if, so bundle block types. There we go. 9.1, section 9.1. So in here, you can see it tells you which bundle protocol version supports that block type, which of course version 6 and version 7 support, the primary bundle block. And then you've got down here, when you get to previous node, you get to the bundle age, and you get to the hop count. Those are only supported in version 7. And then you'll see that we've got some unassigned blocks and some reserved blocks, which we'll talk about in just a moment in this trace file. All right. So if we look inside of here, there are fields inside of fields inside of fields inside of each of these blocks. So with Wireshark, what you might want to do is when you get to a block type, you can right mouse click and you can say that you want to expand the subtrees. And that will expand all of the fields of that block only. So now I can see there's the specific information, previous URI that this came from. I'm going to collapse that block and we'll take a look at the next block. Now this block is interesting. This block is throwing an error in Wireshark. So Jen, you want to tell them why this is throwing that error in Wireshark?
So this canonical block mentions that it is type 193, which in that table in the RFC we can see is reserved for private or experimental use.
Yeah, so I guess when they were writing ION, they decided to put in something like that. And I don't know why. We probably could reach out to Scott Burley and Ginny and ask him, but it might be as an identifier that this is an ION test that they're running, or it could be they want to see, does this break ION, or does it break B-ping? That you have something that's unexpected inside of there, or did the target system just turn around and echo it back anyway? So let's see. So that's this one. Now might be a good time. If this irritates you, this expert notification that, oh, warning, this is a real problem because it's really not. Let me show you how you can change Wireshark's expert severity level for something. So this one right here is what is generating Wireshark's expert information. We can see that it says unknown type code, and it says it's undecoded, doesn't know what it is. There's the protocol for it. And maybe I don't want these to be warnings because I don't think that they're that big of a deal. So as I am clicking on this unknown type code, I can see down below that the syntax for a display filter for this would be bpv7.sub underscore type underscore unknown. All right, I'm going to go up to edit preferences. I'm going to go to expert. I'm going to add an entry in here, and in the field name, I'm going to put in bpv7.sub underscore type underscore unknown. So anytime that happens, I want Wireshark to say, oh, it's just a note. And I'll say, okay. And now we can see that that has changed the color of that issue. It's changed it to this blue. And now my expert will bring it up as just a note. And it will do that anytime it sees an unknown type code. Interestingly enough, it just fully expanded out my DTN section when I did that too. I don't really want that fully expanded out. Okay, so there's that canonical block that is using an illegal number. Okay, then we have the bundle age below that. So there's the bundle age, 2 milliseconds in here. And then below that, we have the payload. So this is what's being sent across the network. You can see when I click on that block for payload, and I click, there we go, and I click on that, then it's just highlighting in the hex dump all of the payload section there, not including that indefinite break at the end, the FF at the end. So that is the payload in here. It's being sent across. If you wanted to, you could keep adding columns up above for the different block types that are in use. You could add a column for the different length values. Let's say we take this type code payload here and I click and drag it up. This is what you'll see in Wireshark. You'll see that Wireshark will tell you every single block type that's inside of each one of these packets. So you just need to add one column for type code. And then you'll be able to see all of the different blocks that are inside of there. What's interesting in here, Ginny, there's our bundle going out, another bundle going out here. There's some echoes coming back. So you may notice when you run this that if you look in your UDP header, you'll see a length value of 150, and then all of a sudden it switches to 151. And we were spending some time looking at this, and Ginny figured out what it was. Do you want to tell them what it is?
This has to do with that CBOR encoding again, specifically how it is encoding the sequence number. When you reach sequence number 24, you now need 2 bytes to say that number. So if you see a sudden uptick of a single byte, it could be an encoding. It could be the encoding causing.
Yeah. So for here, you can see we're at sequence number 30 right here. And this one did start at sequence 27. So we were above that sequence number 24 that suddenly gave us an extra byte. It's very interesting, this encoding mechanism. Okay, so as you look at this, you're looking at these bundles being sent across and echoed back. The same data should sit in the bundles that are being echoed back. Now, we do know that at the end of most of the tests that we've run in ION, you're going to see this one little extra packets showing up, or 2 little extra packets. And we did talk with Scott Burley, who wrote ION and is one of the authors of the bundle protocol. And it's something with the closing process of a thread that he said kind of kicks that out at the end. But you can disregard that last little. It's the toilet paper hanging on the shoe of the test, I guess, something like that. If you have other loopback traffic in your trace file and you don't want that other traffic to be saved, you would put in a filter for ip.addr == 127.0.0.1. You know, you could do 127 dot anything. And when you apply that, you would have this loopback traffic from your test. And that's when you would say export specified packets. Here I've got a directory. Oops, wait, cancel. No, I don't want to replace that one. I'm going to go ahead and call this ion 411 bping. And now we're ready to start the next test. All right, so now I'm going to go ahead and just start Wireshark running. I don't want to save the previous stuff. You'll see it's starting in the loopback interface here, so I want to make sure I'm capturing on loopback. And what are we going to run this time, Ginny?
This time we're going to do BP chat. This is going to spit out a text file from one node that will be reflected back.
So it goes through making sure ION's been shut down from before. And you can see how those dots go across with the traffic. And tells you ION will now stop and clean the node for you. Goes through the cleanup process. We can see that that ION is shutting down because of those spare little weird packets that show up in the trace file. And again, we have that experimental block number showing up, that 193. So here's something I thought was interesting in this one. If we look at the first frame when this runs, okay, at the beginning you have a bping that goes across, and there's our bping payload down there. There's another bping that goes across right here. And then all of a sudden it says, this is some test input to BP chat. So you can read what's actually being sent across. And what's interesting in here is, if you've followed streams before, you can right mouse click and say that you want to follow the UDP stream, but it doesn't make a lot of sense. Wireshark marks all of this the same color because it came from 127.0.0.1 going to 127.0.0.1. Wireshark is not differentiating the communications based on source and destination port number that could possibly be different, or, you know, and it doesn't understand that these are different IPN node numbers on each side of the communication. So you'll see this is some test input to BP chat. And this is it. Now it's being echoed back here. This is going out. And this is being reflected back from this one up here. Here's another thing we noticed when we were analyzing it. When we looked at the conversations here, check out what Wireshark says the conversations are in this echoing process. It says that there are 0 bytes coming from 127.0.0.1 from port 4556, all the bytes are coming from 54,468, port number 54,468. So Ginny and I were looking at this, and it was interesting.
Yep, it's true. They both receive at the same port and send at the same port.
So because of this, we decided in our profile, we wanted to put the source port and the destination port information up in our columns here. And sure enough, look at this. This is stuff going back and forth between hosts, but they both use the same port number for the source when they're sending or echoing back something, which is really, really strange. But taking time to look at this and spend time with Wireshark, changing Wireshark's settings makes it easier for us to understand some of these strange behaviors that are going on using this new protocol. So I'm going to stop the capture at this point. I don't have any other background traffic in here, so I'm just going to say I want to save this trace file. And I'm going to save this one as VP chat. And we'll make those two trace files available to you to work with. Is there anything you can think of that we should share with folks before we go to our closing slide?
I would say when you get the trace files, and definitely do take a look at them, go through the steps to create your own profile. It is the best way to come to grips with the protocol and see its little nitty-gritty details, because there's a lot of that. Plus, there are so many more tests that we haven't touched on in this.
Yeah, spend some time with the other tests and read the README in the ION directory. Wow. Read the README. I am just telling you right now. If you're like us and you just jump in, you know, and, oh, let me just try this and play this, you know, play around with this. Yeah, you can spend a little time going down some rabbit holes. So yeah. Just a warning on that one.
The README will be your friend with this application.
So true. Okay, so let me get back to our closing slide here. So, Ginny, why don't you go ahead and wrap it up for us with this? And I can, if you'd like, Ginny, I can toggle some of these to show them these items on the right-hand side of my screen while you mention what's going on.
Okay. All right. If you want to get ION, you should go to the official page on SourceForge. This is the official release from the folks at the JPL. It's pretty easy to set up once you get the first couple of steps in. Beyond that, I would say take a look at the RFC itself. You are going to hit little details that will throw you off, because Bundle has to work differently from other protocols to tolerate the incredible environment of space. And of course, Wireshark, the Wireshark project, there are tons of resources to help any troubleshooting there if you're hitting technical issues with Wireshark. We also have the Interplanetary Networking Special Interest Group. We are both a member of this group. It's fantastic. It has so many experts who care so deeply about this project from space agencies across the globe. Including NASA, including the ESA, the European Space Agency, JAXA. Yeah, and we also have private groups that have entered.
Yeah, and there's also one really interesting person that's in the group that designed and thought up delay and disruption tolerant networking.
Yes, designing the next internet after he designed the first one. Vint Cerf is part of the Interplanetary Networking SIG. He's very active and he is guiding the formation of the next internet and its governance and its technical aspects as well.
So head out to ipnsig.org. I just want to mention that we have some IPN SIG Academy events coming up. That's a whole series of events running over a 1-year time frame to educate people on interplanetary communications. And then you want to explain to them about our library?
Yes, the Interplanetary Networking SIG library was put together by the Technical Documentation Working Group. It is there to make all of this information as readily available to you as possible. In this library, we have information about the progress of the Solar System Internet Initiative. We have details of specific implementations and some of the crazy cool stuff that these protocols are being used for. It's really easy to go down a rabbit hole here because it's absolutely wild.
Yep. But we did try to tag the library to help people that are newer in this area, or people that really just want to focus on implementation of delay and disruption tolerant networking. So on the left-hand side, you'll see that there's a little tag area at the bottom. And if you don't see it, drag it up. It's just out of your view. And you'll see the history of DTN, Vince's mission to bring the internet to space, DTN for beginners. There are some really great resources here. We also, since some people are more familiar and comfortable with a directory structure with folders, we have folders, and these items are in a folder display. So this is a great resource. And one of the cool things about it is that in this group, you're going to see, let me get back here to our main page. That's Scott Burley. He's the head of our Technical Documentation Working Group. So we've been very fortunate to work with Scott on this. You also see Henry Danielson. He's the one that got us involved in DEF CON to bring in Wireshark analysis of bundle protocol. So
thanks, Henry.
Thanks, Henry. All right. Well, thanks much. And
all right, thank you.
See you in space.
Ad Astra.